Hello, it's 23rd of June. Welcome. I know there are people out there who can sound more sincere than I do. I mean it. Uh, but I'm with Howard the Duck in one of his comics. Somebody, some evil person tries to explain what he's doing, and Howard thinks, I hate it when they go sincere on you. Now, I don't think everybody who sounds sincere is lying, but most of them are. All right. Welcome. As you know, the biggest threat facing the world today, the one that dwarfs all others combined, is infertility and the fact that humans, we're outbreeding ourselves to extinction. There's nothing I can do about it right now because there are lesser problems like this crud virus that's circulating and is such a tremendous threat to places that don't have our wealth and medical facilities. And then there's, civil unrest and some riots and statues being toppled and people wondering why on some of them and so forth. Probably got a famine coming. Red China using its resources, some of which are most objectionable, to buy influence among prestige places in the West. Well, they haven't offered to buy me out yet, so I'm still independent. All right. Alongside all of these other things, and essentially unrelated, oh, did I mention global warming? Is this. Now, I hope you can see this. Let me see if I can enlarge it. Is that a little bit better? This is, as of the 19th, that's 3 days ago, this is the North Pole with what is white being solid ice, or at least 90% ice. What is blue is ice that's broken up, and let's say that glob there is about 50%. So here's this glob right next the North Pole. Let me get something. Yeah, this is globe, right? And good old grammar school globe. This is called a cartouche. Let me write some stuff, document who they are and what they're doing. There was once some people who'd basically mutinied against the Brits, and the Brits couldn't find them, and I swear it's because on all their globes they were under their little island under the cartouche, so they managed to get away with it. They're nice born days. Equator, of course. You can see this thing is mounted so that when you spin it, the equator is okay. North Pole, South Pole. In the summertime, when the North Pole is turned toward the sun, like it's turned toward you now, it's the sun's about 30 degrees above the horizon. At that, the sunlight hitting the North Pole is about half of what it would be if the sun were straight overhead. If the sun is, put you on the equator now, if the sun is hitting the equator and you're standing in the middle of the Sahara Desert, or is it? All right, You're down here on the equator in the desert. It's hot. And in 24 hours, you get 12 hours of daylight and 12 hours of night, and so the North Pole's getting as much at half the rate and half the time. It's getting same amount of sunlight, except that the sun's not always directly overhead at the equator, even when you're at the equinox. So yeah, there's more energy hitting the North Pole than any other place on the world right now, and we're a couple, 3 days into summer. And if you look at the equator, it runs across Africa there, South America there, mostly it's, and bits of islands there. Mostly the equator runs across water. We got a lot of ocean in this world, but not always. Whereas here, 24/7, you got no break when you're over land and half the energy is getting reflected. So, what happens if and when, let me put this down. Thank you. Suppose it's all gone. Well, now the energy coming into the North Pole is greater than the energy coming in anywhere else, and it's being absorbed at a rate that's greater than any place else. And it's black seawater, this kind of stuff, once that gets there, the water is scalding hot, as it would be in the in your dog dish at noon at the equator on the Sahara. And yeah, you get a big updraft, this huge plume of hot, wet air going upward right off the North Pole. Right there, it comes straight out because the heat rises, right? Let's look at some other things. Now then, this might seem a little more reassuring. Here's today's melt line. This line is areas with 15% ice cover. And you can see that this was the worst, the worst year, the year with the greatest amount of melting, and we're matching it. That was the 19th. Now then, today, as the air falls at the North Pole, it sucks in air behind it because the equator is going faster than the Arctic Circle. The air relative to the ground is speeding up. Coriolis effect, it's called the jet stream. Here's a jet stream. Okay, let's just see if we can get this thing to smile for us. And can we get it any more? There. And you look up jet stream and world map, 250 millibars. A bar is 1 atmospheric pressure, as in barometer. Millibar is 1,000th of a bar, so 750 millibars is about 3/4 of a bar. I don't know, they multiply by 1,000 and they have to divide by 1,000 or whatever. Or divide and then multiply. Anyway, at 250 millibars, you're above 3/4 of the weight of the atmosphere. And that's the level at which these folks measure the jet stream. Here's the southern jet stream, for reasons that really escape me. There are 2 components. One a little closer to the equator, the other a little closer to the Arctic. I think they say the air goes coming south. It goes up here and then falls because it can't stay that high that long, and then it comes up. And I've not got a good explanation why you get two components, but you do, and you could get a feel for how robust it is. You know, very big red orange. There's the North Pole jet stream. Should be about the same. Well, first off, you only have one instead of two components, and that component stretches over about half the length of it, so you're down to a quarter of the energy in it. And then each of these is probably a quarter of the... Yeah, that's right. The jet stream is 90% gone. When it's gone, since energy means inherent urge, all that hot air wants to go to where it's cold, which is the South Pole area. So the jet stream, as it loses its structure, is going to try to reach down here and get to this jet stream, and then dump its energy into this Antarctic. Okay. So moving right along here. Is the ice cap on June 20th. We're getting close to where you'd say there's a ring of blue around the North Pole. Look at this long feeler, almost going to the pole. Next, and of course we're still following that line, and the jet stream looks puny, and then we go down to Sunday, June the 21st. And now you just about have the ring of blue all the way around the North Pole. North Pole sitting there with, greater than 90% cover. But of course, remember that feeler that was in there? It suddenly disappeared. That doesn't mean it turned into a solid block of ice. It just means the ice got, or the ice got crowded. Look how close to having a complete circle around the pole. Once you get that complete circle, center's gonna thaw out, and you'll get your scalding rising seawater. And that was the 21st on Sunday. And here's today. They upload at 11 o'clock every morning. All right, we're still following the worst historical line. There's our puny jet stream groping its way southward, and here is June 22nd. That's yesterday. You see that glob there? That is that close to being a thaw at the North Pole. That area is getting today more than twice as much energy than any place else on Earth, hitting it. And as you can see, that's about 50% at the center. Maybe half of it is being reflected. Okay, there's that line, continues to follow the worst previous one. There's the jet stream, and here is this morning. Okay, there's no surprises there. Oh, that jet stream looks like it just took a turn for the worst. Take a look at it. Stretch it out here for you. If I was a computer program, I'd hate me. I'm always pushing them past what they're really designed to do. Okay, puny little jet stream compared with a single day before. It was puny then, but not as puny as it is this morning. And, where are we at the bottom? There we go. And here is today's ice cover. This is 23rd. Okay, it's back. It's breaking up around here. It's breaking up rather quickly along here. The actual amount that's open water, not much worse than it was a couple, 3 years ago. But look at that. At that rate, it's only going to be a few days before we get that upward blast of hot air. It's got to get to the South Pole. The jet stream is going to turn southward, going to carry hailstones. I don't know, average, in a typical good heavy Florida thunderstorm with, one every 250 miles, the hailstones are maybe an inch across, and the winds are maybe 60, 70 miles an hour. That updraft, the winds are going to be 600 or 700 miles an hour. If they break 1,000, we are toast. But, okay, so let's say it doesn't break the sound barrier at that point. And fourth root of 100 is 3. So the wind is going 100 times as fast. So they'll just be like, the hailstones will be like that. And last time, considering the frozen mammoths that have been that fall out of the ice and the grasshopper glacier, the glacier, I don't know, mile thick, you reckon? Clearly formed in a single afternoon, because there were grasshoppers throughout it. Well, grasshoppers can do wonderful things, jumping around on ice. That's not their strength. So the storm came down and the hail mixed with the grasshoppers, and until fairly recently, my father described saying it, there were grasshoppers throughout this glacier. Yeah, that's right. Glaciers show up in an hour or two. Mile thick. Temperature of the ice, of the hailstones, 40 degrees below, stratospheric. Actually, probably get thrown a good deal higher than the stratosphere, because remember the upward going air. Yeah. So, where does it go from there? Well, the jet stream turns south, and it could follow the east side of the Rockies. As the jet stream tries to go straight, the earth turns, so the jet stream tends to drift over the face of the earth. But when it hits the Rockies, it can't really get over them, because you have such a mass of air that it just has to be that. You're up at the quarter of a bar. Well, you're going to quarter of the atmosphere above you. You're going to need like 3/4. So you're way down to mountaintop level. Passes through the Rockies, crosses the equator where the speed of the Earth isn't changing that much, and then it fetches up against the west side of the Andes, and now Earth's getting smaller as you go south, hits west side of the Andes. They keep it from going. So the mountains look like they're arranged to direct the first major onslaught right down the east side of the Rockies, left side of the Andes. If you live in that area, get out. If you have friends in the area, warn them that things may get dicey. Well, yeah, if you want to doom and gloom, all the weight, miles thick and miles high of ice, that'll distort the crust of the earth. The Yellowstone may be triggered. Or who knows, it may go across China. It won't go across India. The Himalayas there will shut it aside. Europe's Europe's in danger, but they have got a number of mountain ranges tend to make it break up. The ocean's the obvious target. Anyway, there you go. A brand new problem. And the worst thing about it is nobody else is talking about this at all. Period. Nobody I've found. Nobody who's saying, oh, they'll talk about a returning ice age and uh, thawing tundra releasing methane. Woo! And smoldering peat fires in the Arctic. Ooh, global warming. Well, yeah, maybe speeding up the rate at which this thing melts, but it's looks to me like a very serious and totally ignore. I mean, screaming global warming is an industry, just like certain other screamings we encounter. Uh, but nobody's screaming ice cap going, ice age coming. Okay, well, have the best of the best. I hate to sound doomy and gloomy, but this is something to think about. Wish the highly paid experts would at least mention it and dismiss it, if nothing else. Um, the but again, all even the returning ice age is not nearly as crucial as having babies. Period. And and so this is really just a diversion. Oh, thanks for dropping by. Hang on a second here. Let's see if I can invent a way to let you go.